Part B, see the same setup that we had previously. We had already discerned that this is our equilibrium position and that the original amplitude AP minus AP was due to the potential energy, kinetic energy, potential energy, kinetic energy, potential. So that the potential energy at AP is equal to the kinetic energy at XO is equal to the kinetic energy at minus AP. And what we determined previously was that the velocity would decrease after block Q is stuck to P because of conservation of momentum. So that means this velocity will instantly decrease, which means its kinetic energy decreases, resulting in a lower amplitude, minus APQ and APQ. And again, that's because less kinetic energy, less potential means less stretch. So how does the amplitude of them compare? Well, APQ is less than AP. Generally speaking, the AP does not award any points for getting this correct. So if one is to go through and put a check here and put nothing, one gets 0, even if you're correct. And it turns out in scoring this one, there's 6 points for Part B. Not 1 point is awarded for getting it correct. Explain our reasoning. Why? Well, actually, I've done that a couple times already. So we can start out with some principles or some definitions. With an object, with an object in simple harmonic motion, the potential energy at AP equals the kinetic energy at XO and the potential energy at minus AP. The energy converts from one form to another with the total remaining constant due to the conservation of energy. So notice we brought in the conservation of energy. Next, we want to comment about that amplitude. Well, what we said was when Q is dropped onto P at XO, equilibrium position, an inelastic EK not conserved, I'm just parenthetically saying what it means, occurs. The P of capital P is now shared with Q, resulting in a decreased velocity. The decreased velocity means a lower kinetic energy. If lower kinetic energy, then less available to convert to potential energy. Since the potential energy of a spring is 1/2 kx squared, and k is the same, then a decreased potential energy means a smaller elongation and thus a smaller delta x, smaller amplitude. So we have used conservation of momentum, conservation of energy to explain all of this. We're trying to use the format of facts, definitions, principles, coupled with the observations of what's happening, with logical reasoning coming through. There is only one weak point in this explanation. That decreased velocity means a lower kinetic energy. You might say, well, wait a minute, the mass is increasing. Yeah, the velocity is decreasing, but the mass is increasing. Well, let's see how that plays out. The kinetic energy is 1/2 mv squared in the first case. So we've got m, and v is the velocity of that system. And this is the kinetic energy of P. Now, what about the kinetic energy of PQ? Half 3m times that new velocity squared. Well, what is that new velocity? We should find out. P0 is P, and that is mv. And afterward, we have a shared momentum, a shared mass of m plus 2m times v prime. And v prime, the new velocity, is mv divided by 3m. M's cancel, we're left the new velocity, v prime, is v over 3. So the new mass is 3m. The velocity v becomes v over 3 squared. So that gives us 3/2 mv squared over 9. 9 is 3. So we have 1/6 mv squared. And we can agree then that this kinetic energy, 1/6 mv squared, is less than 1/2 mv squared. So we just proved that the kinetic energy went down. Now, we don't absolutely have to do this. But to convince ourselves that it's true, I wanted to show you that that's the case. And that's why always that when we have a sticky collision, an inelastic collision, the kinetic energy will be less. Because this velocity will always be less than the original velocity. Because the new velocity will always be less than the new velocity because the mass increased. The squared term means it has an outside role to play in the overall kinetic energy. And this was worth a total of 6 out of the 7 points. 1 point for the previous part, getting the answer, square root of 3. Square root of 3 was worth 1 point.